Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thanks for joining us once again on the podcast known as Space Nuts, where we focus on space, the astronomy, the cosmos, whatever. As long as sorry?
And the nuts.
Who was that? My name's Andrew Dunkley, and with me, as always, is astronomer Fred Watson. Hello, Fred.
Thank you for that introduction. Sorry, I beat you to it.
Oh, that's okay. Look, today could be a particularly horrible show because I'm in a radio station as we speak, and they've decided they're going to install air conditioning this morning, so we might get a couple of hammer drills. We might have people falling through ceilings because this is an old building and I wouldn't like to be up there. And I know there are dead rats up there. And who knows what else. And there are at least 3 mobile phones within a bull's roar of me. So if they're not muted, anything could happen. So let's just press on regardless, Fred. And today we're going to talk about an air leak on the International Space Station, which sounds rather serious. But there's a sinister side to this, perhaps, with allegations of sabotage. Good grief. And the Japanese are set to visit the 162173 Ryugu asteroid. I think that's how you pronounce it. It might be Ryugu. And they're pretty excited about that, as excited as Japanese can get, in fact. And following up on the Perseid meteor shower, we've had a question which opens the door to a whole new array of information about meteor showers. So we'll get onto that. But first, Fred, this rather shocking story of an air leak on the ISS, that's bad enough, but sabotage?
Isn't it interesting? So when this story broke last week, Andrew, it was being sort of advertised as due to a micrometeorite impact.
Mm-hmm.
Micrometeorites, of course, are little bits of space dust. The reason why they're dangerous is because they travel so fast. So natural space dust. In addition to that risk, astronauts up there face the risk from space junk too, which we've talked about before many times. We've all seen that picture of a shard of glass missing from the windscreen of the space shuttle because of a fleck of paint that hit it at 8 kilometers per second.
No, it's just staggering, isn't it?
So natural and artificially made space junk are an ongoing hazard with the International Space Station. And when that story broke last week about the leak in the International Space Station, that was what it was assumed to be. But further examination has indicated that this hole was not actually caused by a micrometeorite. It was actually caused by a drill. That there is a hole drilled in the outer fabric of not the space station itself, but the Russian Soyuz module, which is docked with the space station. And in fact, it's not even the manned capsule of the Soyuz module, the bit that brings astronauts back to Earth, the re-entry module. It's something that we would probably call the service module. It's a module that doesn't have people living in it, but it is pressurized and there is access to it. That has a hole in it. And
Ooh.
The evidence is, people can clearly see when you examine a hole what's made it in terms of the difference between a drill and a micrometeorite. They have quite different structure around the edge of the hole. But there's more of a smoking gun still with this. And that is that, I'm sure, as I do, if you try and drill a hole in a piece of metal without putting a dint with a center punch in it to start with, the drill just wanders all over the place.
Oh, that's what's happened.
And leaves marks. And those marks are there. So whoever's done this has just sort of poked a drill at the wall and started it going, and it's wandered off and marked the metal before it has actually started to drill the hole.
So are we assuming this happened on the ground before the thing was attached, or are we talking somebody on board?
Well, there's two options. Either somebody doing it on the ground or somebody doing it on board. And we don't know the answer to that. It is very interesting. I mean, you can bet your life we will find the answer, I'm sure, because this kind of thing prompts detective work of the most intense kind, all of which at the moment, it has to be said, is being done by the Russians, because this is a Russian, it's a piece of Russian property that's actually got the hole in it. It's possible that it was a mistake that somebody made, on the ground when the spacecraft was being built. It may have been an error that was made and then sealed up, and just to basically cover it up, and then maybe that sealing broke away when it was exposed to the vacuum of space. And because the fact was that we thought it was a micrometeorite, so this leak occurred relatively suddenly. It wasn't something that had just built up over time. It occurred relatively suddenly, as though a micrometeorite had hit it. But if it was a piece of artificial sealant that had been put on it and had come away, then that would have the same effect. It was, of course, just to reassure everybody, it was plugged very quickly. In fact, one of the astronauts, I think it was the German astronaut who's on board at the moment, stuck his finger on it, and that eventually blocked it up.
He was Dutch, wasn't he?
Yeah, it'd have to be. That's right. Oh, thank you. Well done there. It was so that blocked it up, and then they put some sticky tape or something over it. They certainly sealed it up fairly effectively.
A multi-billion-dollar spacecraft, and they've gone to the stationery store to fix it.
Yeah, you bit of gaffer tape or something like that.
Oh, that's good stuff.
Well,
that
it is. We use
stuff.
it all the time in the world of astronomy, but we're not, relying on it to let us breathe.
So I suppose because we don't know how it happened, we don't know when it happened. So we don't know how long the hole existed.
That's correct. There is a comment that's been made by one of the Russian, VIPs who's had experience in space. His name is Alexander Zhelenyakov. I hope that's the correct pronunciation. He's a former space industry engineer and author, and he told the news agency, the TASS news agency in Russia, that drilling the hole in zero gravity would be nearly impossible in that part of the spacecraft. And that yes, that's a good suggestion. But of course, everybody questions why the cosmonauts would do it. There has been a theory advanced that a cosmonaut might do this because because he or she was psychologically disturbed and wanted to force an early transfer back to Earth. But that's not the best way to do that. I mean, I think if you were really in trouble, you would fess up to that and actually have a trip back to Earth with everything well understood and intact, rather than drilling a hole in the space station.
Yeah, I've seen NASA's actually published photographs of the hole on Twitter and probably other social media platforms. It is clearly a drill hole. It is.
That's right.
There's no denying it, and I can see the scorch marks that you mentioned where the drill has slipped. So whoever drilled it intended to drill it.
Yep.
There's no sort of indication that it could have been a sort of a punch through from another surface that accidentally drilled through.
That's correct.
So one wonders why. Maybe it was just a mistake. They didn't. They drilled the hole thinking something was going to be put there and ended up not happening, or who knows? It's a mystery.
Yeah, putting a coat hook in or something like that.
Yeah.
No, I think the
coat hanger would work well on the ISS.
It would on the ISS. That's right. A mistake is certainly a possibility, and maybe if somebody had made a mistake and they were just too scared to fess up to it and then blocked it up, as best they could, and then it's come away, that might be the answer.
Yeah.
I mean, it's a really interesting story. I hope we can bring our listeners more news about it in forthcoming episodes.
Yeah, I'm wondering if that's blue tack around it. No, it couldn't be. But yeah, fascinating. It's not the first time mistakes, assuming it's a mistake, have happened in the space race. Like Apollo 13, that was a mistake with oxygen cylinders. They had a mistake on Apollo 1, which never actually got off the ground because of the fire in the capsule.
Yeah, that was terrible.
Just engineering errors, basically, that surfaced at very horrible times in the case of Apollo 1 and Apollo 13. And this you don't know what this could have led to. Thankfully, they found it, and they've gone down to the stationery store and sorted it all out. I have another theory, though, Fred.
Yeah.
I think they were getting bored and they were probably playing pin the tail on the donkey. I suspect that could have been an issue.
Yes, well, I'll leave that one where it is because...
Yes, we don't want to be an ass, do we?
Not really. Turns out to be that, yes, that's right.
And we'll keep an eye on this. There might be more information on this to come. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, from Russia with love to Japan, and the Japanese have set a date for touchdown on asteroid 162173 Ryugu, which is probably incorrectly pronounced, but they're getting pretty excited. This is a space rock of about 1 kilometre in width. That's a pretty chunky piece of metal and stone, I imagine.
It is. Look, it's an asteroid mission, which I think is very exciting. As you say, it's about 1 kilometre wide, 2/3 of a mile. It's being visited by a spacecraft called Hayabusa 2. And Hayabusa 1 really made history in the early 2000s because that visited another asteroid and actually had an epic tale of things going wrong and things basically coming good. Hayabusa 1 visited an asteroid called Itokawa, which it rendezvoused with in 2005 after a 2-year journey. And the idea was that it was going to collect a sample of the asteroid and bring it back to Earth. And it had the most astonishing series of mishaps. It's far as I remember, it went into a very strange orbit and wound up going past Venus a couple of times. But in fact, it got back in 2010 with a small sample of material from the asteroid.
Yes,
so it was a successful mission in the end. Remarkable.
Yeah, the worst of all, it brought back Pikachu.
Yes, that's right. Probably did. So this is the second version of this, and it's visiting a different asteroid, of course, exactly as you've said, 162173 Ryugu. It's an interesting sort of asteroid. I think it's basically thought to be a sample of the raw material that made up the solar system. So it's one which we could potentially learn a lot about the early history of the solar system by studying. And so there is a plan to bring back a sample from this as well. However, the mission itself has much more scope to it. There's all kinds of things going to happen within the next few months. So the spacecraft has been in orbit around the asteroid since June this year. It took about 3.5 years to get there. And what is now planned, and the reason why this is in the news, Andrew, is because the mission profile has now been released. Later this month, later in September, on the 21st, it's going to launch a little, as far as I can work out, it's about the size of a suitcase. It might be smaller, actually. It's only 3.3 kilograms. A little container which will basically be deployed and will have two little robots on board, each of which weighs 1 kilogram. It's not big stuff, isn't this? It's the size of a packet of sugar or something like that. These two robots have got very profound names. They're called Rover 1A and Rover 1B, and they move across the surface of the asteroid actually by hopping, because they've got it's the sort of thing that's inside your mobile phone. It's as far as I can work out, it's a mass that it rotates and basically sets up a vibration. And this just propels the robot over the surface, so it kind of bounces across the surface.
Wow.
And so these two little rovers, which will be deployed from the Minerva 2-1 package, as I said, on the 21st of September, basically have lots of imaging equipment on board. They've got wide-angle and stereo cameras on board, which will send back pictures, obviously, via the spacecraft itself. And then next month, early in October, there is another lander, which is called Mascot, and that's a joint German-French entity. That will, actually, Mascot's a kind of acronym for Mobile Asteroid Surface Scout. There you go. It's quite a nice one. That's a big one. That weighs 10 kilograms. And that will essentially land on the surface and has wide-angle camera, microscope, radiometers for temperature, things for measuring magnetic field, all that kind of stuff that you expect from a scientific package landed on an asteroid. That also is going to explore the surface. One of the things that is really interesting about this asteroid is that it is covered in boulders, and there's a particularly big one near the south pole of Ryugu. I don't think they're going to go anywhere near that. I think the idea is to stay away from things that could damage the landers. But then once all that has happened, with these two landers that will deploy on the surface, there is a third one, and that, in fact, is going to detonate a small explosive charge to lift material from beneath the surface of the asteroid that will be sampled by the spacecraft Hayabusa 2, which will descend into the crater that's formed and collect the stuff that's there, which is the idea being that you're looking at a sample to bring back to Earth that has not been irradiated by several billion years of cosmic rays and things of that sort. And that will so the spacecraft will leave the vicinity of Ryugu in actually not this year but next year, in December 2019, and come back to Earth about a year later. So amazing stuff.
Oh, it's very ambitious by the sound of it, Fred.
Yeah, exactly. That's the word I was just about to use. It is very, very ambitious. And, they've already tried it once and met with partial success. JAXA, the Japanese space agency, have got some very clever tricks up their sleeve, and I think this is one well worth watching.
So the basis of the mission is to go and see what they can see.
More or less, that's right. You equip with every possible, means of finding out as much as you can, and the icing on the cake is bringing bits of stuff back. And of course, that will be subject to all the normal rules of sample return, which is that it's in an isolated environment. It's not released into the atmosphere or anything like that. It's all properly protected, just in case there's some bugs lurking.
And of course, it just sort of demonstrates humanity to a T. We've spent 3.5 years travelling to this thing so we can blow a hole in it.
Blow a hole in it. Well, we're pretty good at putting holes in things.
We are, and leaving stuff all over the place. But look, you said that this was sort of a leftover from the creation of the solar system. We shouldn't be surprised because builders never clean up after themselves.
Quite so.
Just leave junk all over the place. I've built a few homes over the years. I tried to dig a garden out once to plant about the 5th tree in that spot because they kept dying. And when I dug a bit deeper, I found, aluminium cans and bottles and roof tiles and blue metal gravel. No wonder nothing would grow.
Oh, there you go.
Typical.
You needed the Japanese Space Agency. They'll clear up.
I do. I should have just blown it up. All right. So that'll be exciting. We'll probably talk more about that down the track because, it'll be fascinating to see what they find.
I'm sure we will.
This is Space Nuts. Andrew Dunkley here. And, of course, Fred Watson.
0G, and I feel fine.
Space Nuts.
Finally, Fred, a question from our vast nutty audience. And I might add, next week's episode will be episode 120. And we think we might dedicate the whole show to questions because we've got quite a backlog. And Fred's been asking everybody the answers so he can do the segment for us. So we'll try and answer as many as we can next week. But we'll tackle one right now from Neil McKenzie, Fred, who writes as a follow-up, which seems to be a pretty common thread these days, a follow-up to something we've previously discussed. I have a question following on from your item of August 16. Could have been any other date because, you don't know when people have listened. But he listened on August 16 about the Perseid meteor shower. So if the shower is caused by debris from comet Swift-Tuttle and it orbits the Sun every 130 years, why do we see the Perseids every year? Do all meteor showers come from comets? And do they only appear annually and regularly, or can they be intermittent or even one-offs? Interesting. I think I know half the answer to this question, but I'm going to defer to the expert.
Thank you. No pressure, of course, but thank you very much. So the answer is yes. Neil's question is a good one, and I understand where he comes from. So this is, just to provide the big picture, meteor showers are occurrences which happen regularly throughout the year where we see shooting stars or meteors, all of which appear to come from a single point in the sky, which we call the radiant, and it's always named after the constellation in which that point is, usually with the letters ID stuck on the end of it. So the Perseids are a shower of meteors in August that come from the constellation of Perseus, or appear to, which is actually a Northern Hemisphere constellation. So they're not that good here in the south. But we now understand that the reason why these meteors all appear to come from a single point is because you've got essentially things entering the Earth's atmosphere on parallel tracks. It means they're all coming from the same direction. And it's just the perspective that makes them look as though they're issuing from a single point. Mm-hmm. So parallel tracks of meteors through the atmosphere, and that tells you that the Earth is intercepting a body of little dusty objects that are all traveling in the same direction and effectively at the same speed. And that's how we interpret the origin of meteor showers. So what's happening is the Earth is going through an enhanced cloud of dust in its orbit. And our understanding now, and this comes from the direction in which these meteors appear to come, you can essentially tell something about the orbit of the dust particles themselves around the sun. And it's that leads us to associate them with comets, because when the orbit of the dust particles matches the orbit of the comet, then you know you're on the right track. But Neil's question is a good one, because Comet Swift-Tuttle, which is still, visible in the sky from time to time, it goes around the sun in about 130 years. So why do we see the Perseids every year? And the answer is that comet has been in that orbit for a long time, and it has left a trail of dust behind it. So that trail of dust really spreads around the whole of the 130-year orbit of Comet Swift-Tuttle. That's the one that actually left the debris. And that's true of all meteor showers. Now, there are times when you're going through the orbit of a comet not very long after the comet itself has gone through. And that's where you find an enhancement of the dust. In other words, you're going to get a better meteor shower.
Because the mess is more concentrated.
Exactly, because the debris is not very far. A lot of that debris is going with the comet. It's not far behind it. So there is an enhancement when you're near the time of the comet, but you do see them all the time because the orbit itself is very dusty. The other parts of Neil's question are, do all meteor showers come from comets? As far as we know, they do. Do they only appear annually and regularly? And once again, they do, because of the fact that you're going through a part of the Earth's orbit that intersects the orbit of the comet. So it's an annual occurrence.
Yeah, because we rotate around, we orbit the sun once a year, and therefore we reach that point where the junk is once a year.
Once a year, that's exactly right. We don't know of... Neil asks about, intermittent ones or even one-offs. To the best of my knowledge, there's never been an episode, although, knowing the way the history of astronomy goes, I'm sure I'll be proved wrong, where there's just been a meteor shower that's just come from nowhere and it has happened once and then gone away. We do, of course, see meteors all the time, not ones that are in showers. They're called sporadic meteors. These are just bits of dust that are lurking in the plane of the Earth's orbit. There's a lot of it. There's something like 50 tons of meteoritic dust come to Earth every day. So it's a fairly heavy burden of stuff that's entering the Earth's atmosphere. Of course, it all burns up there in the atmosphere. But the difference between those sporadic meteors and meteors in a shower is that you don't get this effect of the meteors all seeming to come from a single point. They come from anywhere in the sky. You just see them charging across the sky in random directions. So that's the normal occurrence of meteors. In fact, that's, if you go out on any average night and sit for half an hour, you're almost certain to see at least one, and sometimes quite a number. But unless they all come from the same point in the sky, they're not part of a meteor shower. They're the sporadics.
Well, as we mentioned when we were talking about asteroids flying about, there's a lot of junk out there. The universe is a pretty filthy place, and so it stands to reason that there's going to be occasional wisps of something hitting the atmosphere. So how much did you say per day?
50 tons.
50 tons?
Yeah, it's a lot.
It is a lot of dust.
That's right. That's, you think it's dusty in your spare room, but...
Now, I'm going to preempt a question, and I know you've answered this before, but it might come up. You say when these pieces of dust burn up, they get completely destroyed, but they've got to turn into something. So what do they become, and where do they end up?
So they vaporize, and they basically end up as constituents of the Earth's atmosphere. The dust itself is mostly silicates. Sometimes there's iron in there as well. It basically oxidizes, so you get the products of the burning, which become part of the atmosphere. The reason why they burn up so quickly is because of their incoming speed. I think the fastest ones, I can't remember whether it's the Leonids or the Geminids, both of which are coming up later in the year, by the way. The fastest ones hit the atmosphere at 72 kilometers per second. And so, that's a pretty high speed. And they burn up usually around about 90 kilometers high. If you've got a big one, then it'll burn up a bit lower. And one that's big enough to come down to the Earth is, of course, a meteorite. Most of these meteor showers are fairly small particles of dust. They're not terribly big objects. Just one footnote to this, Andrew, is that the next bright meteor shower in our calendar is actually next month, towards the end of October, peaking round about the 21st or 22nd of October, and that is the Orionids, which of course seem to come from the constellation of Orion. Now the Orionids, because Orion sits right on the equator, the celestial equator, it means it can be seen either from the northern hemisphere or the southern hemisphere, so there's no preference with the Orionids. But the Orionid meteors are actually debris from, well, the most famous comet of all, probably, Comet Halley. That's right. So,
wow. Okay,
yeah.
So that's something to look out for later next month. And how long does that one usually last? How long does it usually take to pass through this?
It's quite a long period. In fact, more or less the whole of October, we're going through a sort of fairly broad dust cloud, which is left behind by Comet Halley. But the peak, when you're in the core of the dust cloud, the peak is round about the 21st, 22nd of October.
Looking at the weather, it's going to be globally overcast for the entire month.
Yeah, it sounds like it. It's first quarter moon, I think, as well. So it's actually quite good to see. I think.
Yeah. No, it's fun to just sit out the back and look up for a while and just take it all in. I just happened to be farewelling my son, who was around for dinner the other night, and we looked up and we both saw Mars, and then we just spotted something floating past it. So obviously a satellite or the ISS or something like that passing by. So quite brightly in the sky.
Well, the ISS is unmistakable because it is so bright.
I'd say that's what it was, because it sort of stuck out. Yeah. It's fascinating. And thank you, Neil, for your question. We really do appreciate it. Next week we'll try and tackle quite a few questions in episode 120 of Space Nuts. Fred, thank you so much.
Great pleasure, Andrew. Good to talk as always, and we'll speak next week.
And we got through it without the sound of a hammer drill, which I'm really thrilled about. Catch you next time, Fred.
Sounds great. See you soon. Bye-bye.
Fred Watson, astronomer, talks to us every week here on Space Nuts, and we thank you for joining us every week. Don't forget to tell your friends and say hi to your mum for me. I'll catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.